What is a hydrothermal vent and where on Earth can they be found?
Well, hydrothermal vents basically are cracks in the ocean floor where you have volcanoes making huge mountain chains. And at these mountain chains, you have ocean fluids, they interact with the rocks, and then they spew out what is called sometimes black smoker, which is because it's black because it has very, very hot water, which has a lot of particles in there, mostly iron sulfides. And these ones, they actually are fed by the waters which interact with the rocks in a very hot environment. Now, at the bottom of the ocean, you have what is called a mid-oceanic ridge, which is about 60,000 kilometers of volcanoes, active and non-active, at the bottom of our oceans, which is more volcanoes than we actually have on land. And all those have, in many cases, have hydrothermal vents. And your question is, where do we find them? Hydrothermal vents, we find them only at the bottom of the ocean because we have the same kind of systems on land. They are called geothermal vents, so that's just a difference.
How are they first formed? Where do they really come from?
Well, if you think of any kind of volcano which is fed by, for example, a magma chamber deep down, you actually have either plates which are separating, that means you have what is called spreading, or you have plates which are overlapping, and that means subduction zones. So the fact that these plates change all the time creates magma chambers allowing magma to come up, and that produces volcanoes. That means you have this heat source, and then the waters interact with these hot rocks, and they actually then pump up the heated water at the bottom of the ocean. These can go up to probably 400 degrees Celsius, and the reason why they can go to these temperatures is because you are at very, very big depths, and that's what the pressure then equates that to actually make it to be able to be so hot.
Is hydrothermal activity related to the formation of islands we see, such as Hawaii?
Hawaii is slightly different because Hawaii is not part of the Mid-Atlantic Ridge. It's its own type of volcanic system. But on Hawaii, you have what is called geothermal vents because they are on land. But Hawaii is basically going down from 4,000 meters below sea level to about 4,000 meters above sea level. So it's actually a very, very high mountain. But you actually have these geothermal and hydrothermal vents around Hawaii as well. They happen with every volcano.
Are hydrothermal vents in any way a source of minerals we could use in general society?
Yes, because many hydrothermal vents today, but also much in the past, have led to the formation of many of the ore deposits which we are using. Because if you think about these very hot waters interacting with rocks, they will extract, let's say, copper or gold or silver or tin or lead, and then they actually precipitate them again into ore deposits, which we then mine and used for our use for any kind of material applications or any kind of applications which we need ore deposits for.
Can hydrothermal vents be found on Earth's surface as well as under the ocean?
Yes, they are called geothermal vents, not hydrothermal vents. So if you think about in Hawaii, but if you think of Iceland or New Zealand, or many people heard of Yellowstone, for example, has these geothermal areas where you have hot springs or geysers, which are these places where you have this erupting water coming out from the ground. And they exist the same way at the bottom of the ocean, where they're called hydrothermal vents, and on the terrestrial surface, where they are not in the ocean, they are called geothermal vents, but it's the same principle.
Can we find geysers and hot springs in other places of the world, such as the British Isles?
Not today. You have warm springs in the UK, but that's not driven by volcanic activity. It's driven by just geothermal heating, because if you would drill into an area around Leeds here, you would actually, as you go down, the earth would slowly warm up. And that is called geothermal energy, but that is slowly can be used. So there are people who use sort of like the ground heat to actually heat their houses, but not in the UK. They're not these kind of big geothermal power plants where you can actually extract that at the industrial scale.
Are other geysers and hot springs that we find on the surface as warm as the hydrothermal vents we find in the ocean?
They basically, if you think about it, as water comes out from the ground, it will reach the atmospheric pressure. That means it can only boil. It will immediately boil, and it will boil at 100 degrees if you are at sea level, or at a smaller temperature if you are a bit higher up. But we cannot reach temperatures of 400 degrees like at the bottom of the ocean, where we have much, much higher pressures. So basically, it's just the bad of the thermodynamics to work out on Earth, on the terrestrial surface, because of the 1 bar atmosphere, we can only reach about 100 degrees. In that moment, the water immediately boils, but so they're different in temperature.
what sort of life can be found around geothermal springs, both on land and underwater?
Well, you have to remember that hydrothermal vents at the bottom of the oceans were only discovered in 1977. And the discovery was not because they found bacteria, but they found huge giant clams, or they found these huge tube worms. They found crabs, and they found whole swarms of shrimp around these hot waters coming out. And that was discovery which was surprising because there is no light down there. So they had to figure out how does that live, whatever they found. They found lots of different types of animals.
So how can they possibly survive without energy from the sun for photosynthesis?
We live with photosynthesis. Most animals have photosynthetic activity, but there's lots of animals and plants which live without light, and that's called chemosynthesis. So they actually use chemicals to metabolize. For example, you could use the sulfur or the iron which comes out of these hot springs to actually metabolize. So you use, for example, sulfur, and you take sulfate or sulfide, which is a different form of chemistry, and you just take the electrons away and actually transform that to a different type. So if you go from sulfate to sulfide, for example, that is 8 electrons, and that is food. For microbes, that is food. And
electrons are food.
Electrons are food. And then if you are a microbe, you become food to the next level up. That means a shrimp will eat you, a crab will eat you, you feed part of the tube worm. So it's a whole chain of plants and animals there which actually live from the microbial chemosynthetic processes. And it's called chemosymbiosis because they live together.
So how did life first get to such a harsh environment and evolve to be sustainable there?
Well, that's a $60 million question, because basically there have been some experiments where if a new vent appears somewhere, a new volcano appears somewhere, they have discovered, they went back a couple of years later and they realized it's totally colonized. You have to remember that, for example, in the ocean, there's planktons. Many of these little spores or bacteria can be transported vast distances in the ocean, and actually the colonization of even the furthest part of the planet is very easily done under the sea. How they happened in the first place, you're talking about the origin of life story, which is a very different discussion, but there is a potential discussion that it is likely, or some people think, that life may have originated at these hot springs because it provides enough energy and enough chemical energy to actually feed the original proto-life. So that's possible.
So if you get a new hydrothermal vent, how does the first crab make its way there?
Well, the first crab will only make its way there once all the other animals which the crab has to eat have arrived there. That means you start with bacteria which come with the ocean, and then slowly but surely they will just migrate, because crabs are not all sedentary. We think of crabs as sedentary, but actually they migrate, and they can migrate very long distances.
Do we find geothermal springs on other planets or even on other moons in our solar system?
There are indications, chemical indications, that there were geothermal springs on Mars before, because they found chemicals and minerals like they are formed today on Earth from geothermal systems. For example, they have found systems where they have silica precipitation, which is shown to form similarly on Earth. If you heard of Enceladus, Enceladus has shown that they have these geysers, which are water geysers, which come out from the Enceladus. Many of you must have seen the pictures of Enceladus. So geothermal and hydrothermal activity is not a unique system of Earth. It's just that it's much, much easier to study here than somewhere else.
Can geothermal vents be used to produce electricity for domestic use?
Yes, if you think of New Zealand or maybe South America like Chile or Indonesia or Iceland. For example, in Iceland, about 80% of the total energy, whether they use for heating or for electricity, is actually produced in geothermal power plants, because they actually just drill into their ground for a couple of kilometers and they extract the hot steam and water, and they actually produce electricity from that by passing into turbines. It's more difficult in a place where you don't have volcanoes like in Iceland or in New Zealand or Indonesia, but it's very, very much possible. And they produce 80% of their energy through geothermal power plants.
Is it a sustainable source of electricity, and will it ever run out?
Sustainability is a very difficult concept, because we think sustainability in maybe a couple of years, hundreds of years, or tens of years. If you think of the life cycle of a volcano, or of Hawaii, for example, or Iceland, I mean, the mid-ocean ridges, they have existed for 200 million years, so they will continually exist. So it is sustainable, and the production of energy will become better and better. And Iceland, since they actually developed geothermal energy, I think in the 60s, has been running like that. Sustainable in what sense is a bit more difficult to decide, but I think, yes, it's much more sustainable than petroleum, because we'll run out of that, while geothermal energy will be there forever.